what, it's Data Night and welcome back to my channel, and today we are going to talk about bias and variance trade-off. Alright, let's get started.
We're going to discuss about bias and variance trade-off, an example of bias and variance trade-off, and then we can look at a practical section on how to plot a learning curve. So what is bias? Now, in dictionary, bias means something or when something is biased, it may actually be favorable or not favorable. Bias is in favor or against the idea. So bias in machine learning is actually the difference between the model average prediction all over the accurate or the actual correct value. In the layman terms, bias has its own ego and it obviously doesn't care about the data. So bias can actually lead to a term called underfitting, because when you have a high bias, it makes assumptions without even caring about the data. So the bias is not in favor of the model. Exactly. So now let's look at the next step, which is variance. Now variance means inconsistency or inconsistent. When something is inconsistent, it's variance. Now variance in machine learning is the viability of the model prediction for a given point or the value, which tells us the spread of our data. In the layman term, variance is the rate of inconsistency in your model. So when your model is actually working on your train set and it doesn't actually replicate that same performance on your test set, it's lack of inconsistency. Okay, so model with high variance actually pay attention to the training data and does not generalize on the new data, which actually lead to a term called overfitting. Now let's look at underfitting and overfitting. We mentioned two terms. What is underfitting? Underfitting happens when your model is unable to capture underlying pattern in your data. This model usually have high bias and low variance. It happens when you have a very less amount of data to build a model. And when you're trying to build a linear model with a non-linear data, that's when you have a high bias and low variance, which leads to a term called underfitting. Now overfitting happens when our model captures a lot of noise along our underlying pattern in data. It happens when we train our model with a lot of over noisy data set. This model will have low bias and high variance. Now let's look at what we call bias and variance trade-off. Now bias and variance trade-off is actually a term that or is actually the optimal bias and variance trade-off is the optimal balance of bias and variance. In bias and variance trade-off, you need to understand that total error needs to be minimized. To build a good model, you need to minimize total error. Now to find total error, we need to use the formula called bias raised to power 2 plus variance plus irreducible error. Let's look at the illustration for bias and variance. Now you can see this is the bullseye diagram. And for every middle is the real target. So the actual target is the real middle, And you can see this has a low variance and a low bias, which is bias and variance trade-off. Now, it's at the middle, which is the right target. This is scattered, it's not at the middle, which is the right target. So that means it has variance and low bias, which leads to the term we mentioned earlier, overfitting. Now, the next one is high bias. It actually doesn't even reach the middle. Like it's not even close. This is off point. So it leads to the high bias and low variance, and this one is actually high bias and high variance, which is totally or rarely possible. Exactly. So this is another illustration that showcases the overfitting, underfitting, and the good balance. Okay, so you can see how it your model perform over time with this kind of diagram. So in case you're plotting or something. Okay, so let's look at this particular diagram, which is called the learning curve. Okay, so we're going to talk about learning curve in our practical section, and you can see over here that we have the target or the desired accuracy, we have the training accuracy and the validation accuracy. The validation accuracy can be the test accuracy. Okay, so one of the perfect way you can actually know that your model is optimal for bias and variance, or it has bias and variance trade-off, is when the gap between the target desired accuracy, the training accuracy with the test accuracy is very close. Okay, now let's look at a little illustration to differentiate between overfeeding and underfeeding. Okay, so imagine you actually have a brick and you actually want to use this brick to build a house, but it totally doesn't fit very well for the house. Because why? The brick doesn't work for the house, so it's not feasible for that particular kind of architecture. Now, the next one is overfeeding. You have a brick, you use it to build a house. Oh, it looks nice, that's amazing. But now you try using that same brick to build another house with the same architecture, and it obviously doesn't work very well for you. So that way, you actually experience what we call overfeeding. Now, how do we achieve bias and variance trade-off? We achieve bias and variance trade-off by using the following techniques. You can actually use any of the techniques. Okay, so it depending on what techniques you actually desire to use. Okay, so the first one is bagging and resample technique. The next one is regularization, and other one is adjusting minor value in the data set and using the proper machine learning workflow. So maintaining a separate train and test set, trying out appropriate algorithm. The last one is hyper-tuning, which is called hyperparameter optimization or tuning. Exactly. So therefore, digesting bias and variance is vital for understanding the behavior of a predictive model. And you also need to see an example of a model which has the bias and variance trade-off. Exactly. So we are going to move into the particle section. So this is the particle section, and in this section we are going to talk about the learning curve. So learning curve is actually a graphical presentation of the model performance over the experience of time. Learning curve shows the relationship between your training set size and your choosing evaluation metric, either mean square error or accuracy, on your train set and your test set. Learning curve is actually vital when you're diagnosing or you're detecting bias and variance. The first thing we do is to import the package. So we need to import the package from sklearn with model selection, import learning curve. And then we create a train size, test score, and train score with our learning curve function. So here is the parameter for the learning curve function. So the first parameter on our learning curve function is the parameter is the estimator, and the estimator is the model, the algorithm model. Now the next one is actually your independent and dependent variables, which you put on, and then we can pick up the scoring method. What particular scoring method do we want to use? We want to use the mean square error, but in this video we're going to be using the accuracy scoring method, and then we can now pick our training size. Exactly. So the next one we're going to do is actually to create a mean and standard deviation of the train set and the test set. So we've created the training set mean and we've created the standard deviation. We've also created the mean and standard deviation for the test set and the standard deviation. Yeah, the mean and standard deviation for the test set. So now let's move on to plotting our learning curve. Now, this is the code to actually plot the learning curve. So first thing we do, we call in the plot function for the train size and for the test set, and for the train and test, train score and for the test score. And then we draw a band. So the band is actually this, which is the desired accuracy. Yes, so we now create the plot using plots. Now we've created the plot, and if you take a look at this plot, you can see that we have the test score and we have the train score, and the gap between the test score and the train score is little, like you can't actually see the gap actually. So look, the gap between the the desired accuracy from the test score and from the train score is minimized. So this is an awesome graphical presentation of bias and variance trade-off. So right now, being able to see bias and variance trade-off, you need to try it yourself. And if you have any error, don't forget to send me a DM or put the error in the comment, and I'll always reply you. All right.
Right now, I'm able to see bias and variance trade-off. Thank you so much for watching this video. See you in my next video. If you like my video, click on the subscribe button.